So you probably woke up at 3 a.m. wondering what the future of grid storage batteries are. No? Let me talk about the lithium industry and where it's heading to. In a lithium battery, there's a liquid electrolyte that is actually flammable. And the industry is trying to move to solid-state technology. And essentially taking that liquid electrolyte and replacing it with a ceramic piece. That is the solid state. And it allows the lithium to go back and forth. Now, the lithium battery industry is concerned about lithium-ion battery fires. Essentially, it's a thermal runaway, very difficult to put out because it generates oxygen at the cathode end of the battery. A lot of people don't realize that lithium batteries have a limited temperature range. So at 0 degrees, your battery drops to 70% capacity. So if you have an EV vehicle in the very cold climates, it's a concern. Lithium-ion batteries don't actually operate that well also in desert conditions. So essentially, in a lithium battery, there are a lot of cooling fans. Nearly 30% of the energy in a battery is used to cool the battery down. So it actually doesn't operate well in very hot climates. The other thing is that the life of the battery is generally 8 years. In grid storage, you have to replace those batteries after 8 years, and it's a high capital cost. So also the industry is concerned of critical minerals in a lithium battery. Obviously lithium, you've seen the price of lithium being very volatile in the last few years. Graphite, 90% of graphite comes from China. So it represents a geopolitical risk, and the industry is concerned about that. And then cobalt. 70% of cobalt comes from the Republic of Congo. The industry is concerned about ethical supply of cobalt when you have child labor issues coming from that supply. And then finally, copper. There is enough studies that show copper mines needs to double to even meet the demand of EVs. So my question to you, ladies and gentlemen, is there a battery that is actually totally fireproof, operates in a large temperature range, and more than 15 years life? A battery that is lithium-free, cobalt-free, graphite-free, copper-free, and manganese-free. So introducing you to the Serenergy battery. Basically, it's a salt battery with nickel metal powder. The technology was developed by the Fraunhofer Institute in Germany over 8 years, and they spent nearly 35 million euros developing this technology. The chemistry's been around since the 80s, but the development is into the grid storage market. We have a joint venture with Fraunhofer where we own 75% of the project, and we're commercializing these batteries. As you can see here, the ceramic piece sitting in the metal cylinder. Each of those batteries are about 240 watts, and the best part of it is totally fireproof. They also can operate down to -40 degrees and up to temperatures of 60 degrees. And the reason for that, it has its own temperature regulation. When you charge the battery, it's endothermic, and when you discharge the battery, it's exothermic. The life of the batteries is beyond 8 to 10 years, up to 15 years or 6,000 cycles. So nearly double the life of a lithium battery. And the best part of it is the life of the battery operates in a wide temperature range. And we don't have any lithium, we don't have any cobalt, graphite, and so on. So how does the battery work? You've got a ceramic piece, which is the solid state. So it is solid state technology. And in the middle of that ceramic piece, we add salt and nickel metal powder. There is a positive probe in the middle, and the ceramic piece sits in a metal canister, which acts as a negative part of the battery. And you can see the picture of that ceramic piece in the metal cylinder. The beauty of the technology is when you charge the battery, sodium ions migrate through the ceramic piece, which is solid state, and it forms molten sodium on the other side of the battery. It's a self-forming anode. There's no copper, there's no graphite. The nickel is there to grab the chloride and allows the sodium to migrate. Okay? The unique part of this battery, it's a self-forming anode. When you charge the battery, it forms the anode. When you discharge the battery, it dissolves the anode. So hence, you don't need any copper, you don't need any graphite. So if you look at the discharge, you can see the sodium ions now migrating back, going through the ceramic piece, grabbing the chloride, and then becoming salt again. So very neat chemistry. How does this battery compare to other batteries? If you compare it to the lithium iron phosphate batteries, very similar energy density. The beauty is that the life is double. CapEx is much less because we don't have all those critical minerals. But the most important thing on that slide is the maintenance costs. There's hardly any maintenance costs. We don't have any cooling fans that we have to maintain. So very similar energy to LFP batteries. And in the end, we need all batteries to come online for the future. If you look at this graph, the bottom axis is how much energy a battery can transfer, and the vertical axis is how much power. So if you look at the red bit, the lithium ion at the top are nickel cobalt batteries, lots of power, and the bottom bit are LFP batteries, just a lot of energy that you can transfer. The beauty of our batteries is we sit right in the middle. We can provide energy as well as some power. So this is critical for the grid storage market. So our target market is the grid storage market. Let me explain to you what grid storage is. Basically, we have a lot of solar farms being built, wind turbines, and we're generating a lot of electricity during the day. Unfortunately, there is a surplus of energy during the day, and countries are actually discharging that energy to the ground. California wastes $3 billion every year, Germany $2 billion, and even Australia discharges renewable energy to the ground because during the day, there's just too much power. People are surprised about that. What happens when EVs come online? Well, they won't be able to charge straight from the grid. You have to have some storage. So grid storage is very simple. Big batteries sitting on the grid. During the day, when the sun's out, you charge these batteries, and at night, you discharge it. It's called energy shifting. Now, in some countries, during the day, power is actually at a negative price. Not 0 cents, not 1 cent, negative. People have to pay to put their renewable energy onto the grid because there's so much power. All right. The Fraunhofer Institute has spent nearly 25 million euros in a pilot plant. They've built these batteries. They're operating. So this is not a research and development project. We're not starting from concepts. They have built these batteries and they're operating. So that's a 5 kilowatt battery under tests, and they've built 10 kilowatt batteries and so on. We were selected as a joint venture partner. We own 75% of the joint venture. And you can see some of the equipment here. They are actually producing the ceramics using alumina. There are a lot of additives that go into that allows that transfer of sodium, solid state technology. These tubes have to be sintered at 1600 degrees, high temperatures. And then you can see a picture of these tubes going. This is a 10 kilowatt battery undergoing tests. You take a cross section of that, you can actually see these cells, about 240 watts per cell. So our joint venture is to build a 120 megawatt battery plant in Saxony, Germany. So you can see here one of these cells. Saxony is on the border of Poland and the Czech Republic. And there's a lot of activities in electric vehicles and battery plants in Saxony, Germany. This is what our plant will look like. We're just in the final stages of launching the DFS. As you can see, a lot of solar panels on this plant. We use a lot of renewable energy, and we will be accredited as a green project by Cicero. This is our basic battery model, 60 kilowatts, 100 amps, 600 volts. There are 240 cells of these. We will then put it together into a sea container. 18 of these will go into a sea container, pre-assembled, and you can deliver this to your site just on the back of the truck, drop it on deck. So there's very simple installation. Drop it on deck, plug and play, and you have 1 megawatt connected to your grid within 5 minutes of delivery. If you know lithium-ion batteries, that's impossible. Lithium-ion batteries have to be delivered in pieces, assemble on site, install, and so on. We are now finishing a DFS. We've designed the plant, and we have to produce one of these cells every 45 seconds from scratch, right? So the technology that we use is all German engineering. And the best part of it, with the auto industry in Germany, they're very used to automation and robotics. So this plant, as I said, we are going to announce the DFS, very exciting technology. And we are also now talking to European banks on this project. They're very interested, and also grants. As you know, a bit like the IRA, there's a lot of money swirling around in Europe looking for these green projects, and we have commenced that grant application. We are also building 2 prototypes. So this is the first battery, the 60 kilowatt prototypes, and you can see some vision here of the prototypes being built, right? They had to modify the pilot plant to build these 60 kilowatt prototypes. As I mentioned, these ceramics have to be sintered at 1600 degrees. Once they're completed, they undergo some quality checks. It's key that there is no defects in these ceramic pieces. They then slide into the metal cylinder, and that acts as the negative part of the battery. And then within that battery, we add sodium chloride, salt, just common table salt, and nickel metal powder as granules. These batteries are then welded. The tops of the batteries are welded, and then they go through tests under temperature. So essentially, our basic model is a 60 kilowatt pack. And the number of people around Australia that ring us up and say, you know, can I get access to one of your batteries? Well, we really focus on Europe and the grid storage market. So we are talking to some off-takers. They're generally 2 German utility companies that are destined to go to renewable power. So they want batteries, and they would like all kinds of batteries. LFP batteries, our batteries, or redox flow. Here you see some vision of our plant design. As I said, 120 megawatts. We're looking to finalize some of the offtake, and within a couple of months we'll be announcing our DFS, and I would like you to join our journey on the grid storage sector. Thank you.